It's algebra time, and today's lesson is lesson 2-3. Today we're going to multiply rational numbers. Now, first of all, let's figure out what is a rational number. Well, it's a set of numbers, actually, and it's a set of the numbers that can be written in the form A over B. You know what that means. Yep, rational numbers are numbers that can be written as fractions. But don't worry, there are plenty of rational numbers that aren't fractions too. And we're going to be multiplying those today. But let's continue with the definition. Now, if a rational number is a number that can be written in the form A over B, A and B are going to be integers. That means they're going to be relatively easy fractions. And remember that since you can't divide by 0, B, in other words, the denominator, cannot equal 0 either. So, as a quick recap, rational numbers are any numbers that can be written in fraction form, and remember that the denominator of any fraction is not allowed to be 0. Now, we do have a couple of key concepts that I want to make sure everyone totally understands. The first one is that the product of two numbers that have the same sign is positive. All right, let's put that a little bit easier. If we multiply a positive number times another positive number, the answer is going to be positive. Or if we multiply a negative number times another negative number, the answer is going to be positive. So once again, when you're multiplying two numbers that have the same sign, the product, in other words, the answer, is going to be a positive number. So let's look at the other key concept. It says that the product of two numbers that have different signs is negative. And again, in a little bit easier terms, what that means is that if you multiply a positive number times a negative number, the answer is going to be a negative number. Or if you multiply a negative times a positive, you're going to get a negative answer. So once again, to just have a quick recap, the product of two numbers that have different signs will be a negative answer. Now, please remember those two key concepts because they're going to rule the multiplication problems we're going to do today. Okay, so today our example problems are going to focus on two particular types of problems. First of all, we're going to take a look at multiplying integers and or decimal numbers. In other words, we're going to multiply integers together, multiply decimal numbers together, or multiply an integer times a decimal. Now, again, remember the key concepts. If you multiply two numbers that have the same sign together, answer is going to be positive. And if you multiply two numbers that have different signs together, the answer is going to be negative. That's going to apply for all of these multiplication problems. Then the second kind of example problems that we're going to do is we're going to multiply big bad fractions together. So really pay attention to those. Here we go with the example problems. Here we have four examples showing our rules for multiplying integers and decimal numbers together. Take a look at number 1. We have a positive 8 times a positive 11. And according to our rules, we know that a positive times a positive will give us a positive answer. So all we have to do is worry about multiplying 8 times 11, and that equals 88. No big deal, right? All right, let's take a look at number 2. Now we have a negative 5 being multiplied times negative 13. Again, our rules said that if we multiply numbers that have the same sign, in other words, in this case, we're multiplying a negative times a negative, then our final answer or product is going to be a positive number. So again, a negative times a negative is a positive, and now we just have to worry about correctly multiplying 5 times 13, and of course that's positive 65. Hanging in there? Keep going, we got a couple more. Number 3, we have a positive 7 being multiplied times a negative 2.1. Now, it doesn't matter that one of the numbers is an integer and the other one is a decimal number. The rules still apply. And what are we doing in this one? Well, we're multiplying two numbers that have different signs. We're multiplying a positive times a negative. So that's going to give us a negative answer. Now, let's just do the multiplication. 7 times 2.1 gives us a negative 14.7. And finally, it doesn't matter if the negative is the second number being multiplied or the first number multiplied. In number 4, we have a negative 6.8 being multiplied times a positive 0.5. But again, we're multiplying two numbers that have different signs, a negative times a positive. So we know that our final answer will be negative. So let's do the multiplication. 6.8 times 0.5 is going to give us a negative 3.4. Pretty easy so far. All right, now it's time to try some fraction multiplication. Okay, we have a couple fraction problems to do here, but we can handle it. Just remember, when you're multiplying fractions, you're going to be multiplying the numerators together, and then after that, you're going to be multiplying your denominators together. So let's take a look at number 5, remembering our rules. What kind of fractions are we multiplying together? That's right, we're multiplying positive fractions. A positive times a positive will give us a positive answer. So in number 5, before we even start doing any multiplying, we know that we're going to have a positive answer. Kind of make sure that you think through what kind of answer you're going to have before you even start to do the multiplication. It'll help you get them all right. Okay, now let's multiply the numerators together. 3 times 7 gives us an answer of 21 in our numerator. And 5 times 2 gives us an answer of 10 in our denominator. So our final answer is 21/10. Pretty easy so far. Let's try number 6. Now again, stop and think. What kind of fractions are you multiplying together? You're multiplying a negative times a negative. And what do the rules say? The rules say if you multiply two numbers, any kind of numbers, including fractions, that have the same sign, your answer is going to be positive. So we know a negative fraction times a negative fraction will give us a positive answer. So now that we know our answer is going to be positive, let's just worry about doing the correct multiplication. So again, multiply the numerators first. 5 times 2 is 10. Now multiply the denominators together. 9 times 3 is 27. So we have a final answer of positive 10/27. Now those are pretty easy. Let's try a couple of fraction problems where we can do some cross-canceling. Remember that? In example 7, take a look first at what kind of fractions we have. We have a negative fraction times a positive fraction. Now again, every single time you do a multiplication problem, be thinking of what kind of answer you're going to have before you even start to do the multiplication. You've got a negative times a positive. That means our answer is going to be a negative answer. Let's put that in right now so we don't forget. Phew, I feel better. Now I know that I'm going to have the correct sign in front of my answer. Now I just have to make sure that I do the multiplication correctly. Now, we could just go ahead and multiply 5 times 24 and then multiply 8 times 10 and then reduce that fraction into lowest terms for our final answer. But here's an easier way. Maybe you can cross-cancel numbers if they have common factors, which in this case they do. Take a look. The 5 in the first numerator will divide evenly into the 10, which is in the second denominator. And the 8 in the first denominator will divide evenly into the 24 in the second numerator. Now we can cross-cancel, and that accomplishes basically reducing our fraction to lowest terms before we do any multiplying. Let me show you how it's done. We see that obviously 8 divides into 8 one time, and 8 divides into the 24 3 times. So we've cross-canceled to basically reduce down the 8 to 1 and reduce the 24 to 3. Now we also know that 5 will divide into 5 one time and will divide evenly into 10 2 times. So again, we can cross-cancel the 5, and what's left on top? 1 times 3. So all we have to do to get our final answer in the numerator is multiply the 1 times 3, and in the denominator, multiply 1 times 2. So let's go ahead and do that and get our final answer. So as you can see, our final answer is negative 3/2. Now you can leave it as an improper fraction, that's fine. You don't have to feel like you have to change that into a mixed number unless your teacher tells you to. If you have me for a teacher, don't worry about it. As long as the improper fraction is reduced to lowest terms, you're in good shape. Let's try another one. Well, you may be looking at this problem and go, wait a minute, I thought you said we're multiplying rational numbers today. Well, guess what? Mixed numbers are rational numbers too. Yep, we can write them as fractions, and actually that's exactly what we should do first. See, mixed numbers are really tough to multiply and they're tough to divide. But if we change them into fraction form first and then do the multiplication, it makes life a lot easier. So let's go ahead and change those two mixed numbers into fractions. Okay, so we took the integer part of the mixed number 2, multiplied it times 3, which of course is 6, and then added to the current numerator of 2. 6 and 2 gives us an improper fraction of negative 8/3 for the first fraction. Now, don't lose the negative. The mixed number, the first mixed number was negative, so that means the first improper fraction has to stay negative. Then we go to the second mixed number. We multiply the integer part of the mixed number 3 times the denominator, 4. 3 times 4 is 12. And then add it to the numerator, and we get an improper fraction of 13/4. Now that's going to be a lot easier to work with. Now please remember that since we have a negative fraction times a positive fraction, you see I've already written in that my answer is going to be negative. That way I don't have to worry about messing up on the sign for my final answer. Now also look for any factors that the numerators and denominators have in common, because we want to cross cancel if we can. See, that way we don't have to reduce to lowest terms at the end because our answer will be reduced. So let's see, I think I see the 4 and the 8. We can do some cross canceling, can't we? Let's do that right now. And as you can see, we cross canceled the 4 with the 8. 4 goes into 8 2 times. So that means for our final answer, in the numerator we have negative 2 times 13, and in the denominator we have 3 times 1. And that means our final answer is negative 26/3. Now let's just do one more practice problem, and I'm going to make it a little bit tricky, so watch out. Okay, example 9, and hey, this is algebra. You knew I had to throw in some variables at some time, right? Now, just remember, since you see variables in there, don't get freaked out and forget all the other rules that we've learned. Remember, in this problem, you're still multiplying a negative number times another negative number, which means your answer is going to be positive. Always think of that first. Okay, now that we have that out of the way, now start thinking, is there anything I can cross cancel before I do my multiplication in order to make this an easier problem? Well, yeah, 3 will go into 9 3 times, so we can take care of that right now. Okay, that looks better, but we're not quite done. See, you can cross cancel variables that are alike also. See those x's? Well, first the 7x is in the denominator of the first fraction, and the 4x is in the numerator of the second fraction. Now, as long as one of the x's is in the numerator and one is in the denominator, and we're doing multiplication, we can cross cancel those completely. Yep, they will cancel each other out. Let's do that right now. Well, we did our cross canceling, and as cross canceling problems get a little bit messier, you may want to circle what's left to multiply. Now, remember, we already knew that our final answer was going to be positive, right? Because it was a negative fraction times a negative fraction. Now, what do we have left in the numerator to multiply? Well, we have 1 times 4. Good. Gives us a final numerator of 4. Now let's take a look at the denominator. What's still in the denominators? Well, we've got a 7 times 3, so that makes our final denominator 21. So it looks like our final answer is 4/21. Well, I hope these practice problems help you do your homework very easily tonight. Do a fantastic job, and we will see you next time.